Exercise 1.1, question number 2 is, show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, and where q is some integer. Now first of all, I would like to explain you the meaning of 6q plus 1, 6q plus 3 and 6q plus 5. Yesterday you had watched the video regarding the Euclid's division lemma, right? So now we are using Euclid's division lemma here, which states that A is equals to BQ plus R, where R is greater than or equal to 0 but should always be less than B. In other words, dividend is equal to divisor into quotient plus remainder, and remainder should always be less than divisor, and remainder can be equal to 0 and can be greater than 0. I'll explain this concept by taking few examples. For example, if I have to divide 15 by 4. Now I am going to do few divisions. You people will tell me, you people will check which division is correct. Suppose if I write 4 2s are 8 and remainder is 7, or if I write 15 divided by 4, 4 3s are 12, this I can also write 15 on dividing by 4, 4 1s are 4, and so remainder is 11. Now I have done 3 divisions here. You can easily tell this division is not correct. Why is this division is not correct? Because you know it can be done like 4 3s are 12, so we are getting remainder 3. Even this division is also incorrect. Now I tell you why you people can easily say these divisions are incorrect. The reason is, this is the remainder. Here remainder is 7 and here remainder is 11. In both the cases remainder divisor से बड़ा है. Either way this is 11, it is greater than divisor which is 4. But this division where the remainder is 3, this division is correct. The reason, remainder is less than divisor. That is why this condition is important. That is, remainder should be less than divisor. It can be equal to 0 and it can be greater. That every odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. If you compare it with A is equal to BQ plus R, then you can easily observe that in place of B, 6 is written and the values of R are 1, 3 or 5. Basically it means, suppose we have any odd integer. So like odd integer I am considering, suppose let's say 81. It's an odd integer because there is a 1 at its ones place, so it is the odd integer. If I divide it by 6, 6 1s are 6, bring down this, 6 3s are 18, so remainder is 3. That is, we are getting, on dividing by 6, we are getting remainder as 3. Let's take another example. Suppose if I write 11. Now if I divide 11 by 6, 6 1s are 6. On dividing by 6, I am getting remainder as 5. Now let's take another example, 7. If I divide 7 by 6, 6 1s are 6, so remainder is 1, that is this. So if you consider, you can try this by taking few odd integers, and if you divide all those odd integers by 6, either you will get remainder 1 or 3 or 5. You will not get any other integer. If you want to check, you can check it. You can easily just pause the video, assume few odd integers and divide it by 6. In all the cases, you will be getting either remainder 1 or 3 or 5. Now this is the meaning of the question. That is, every odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5. Let b is equals to 6. Since in this condition a equal to bq plus r should always be less than b and greater than or equal to 0. So it means r can have values less than 6. So therefore r can be 0, 1, 2, 3, 4 or 5. So now we have 6 cases. Now first case, if r is equals to 0. Now a is equals to bq plus r. A is here. The value of b we assumed is 6 and the value of r we have considered as 0. So 6q plus 0 is 6q. 6, if I want to write, I can write it like this. Why? Because if this shows this is an even number. Because if you multiply any number by 2, it is always even. Now, if r is equals to 1, so a is equals to bq plus r. What was the value of b? It was 6. And it is, remainder is 1, which we have considered. Again 6q, that is this, and plus 1 like this. Now 2 into 3q, this is even. And if you add 1 to any even number, you always get odd. Right? Now let's consider third example, third case, if r is equals to 2. A is equals to bq plus r. So a is equals to 6q plus 2. Now I can take 2 common from each term. So I'll get this. Now again, any number multiplied by 2 is even. Now do one thing. Pause this video and try to write the cases for remainder 3, 4 and 5 yourself, right? Then continue this video and check whether you have done it right or wrong. If r is equals to 0, we got even number. If r equal to 1, we got odd number. If r equal to 2, we got again even number. And by taking r equal to 3, we are getting odd number because this is a even number. If you add odd number to it, you get always odd. If r equal to 4, so we get an even number. And if r is equals to 5, again we are getting odd number. Now just see, in case of r equal to 1, r equal to 3 and r equal to 5, we are getting odd numbers. So we can say every odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. I hope you have understood the concept. If you are facing any problem, re-watch this video. Again, if you are facing any problem, you people are free to call. And there is an assignment after on the school website. You can see and you can practice few more questions. Thank you.